Hello, good evening. This is Professor Khan, and this is Heat System Design EST-204. And this week we'll be discussing lighting and appliances. And uh, again, this is after the midterm, and this will apply to a lot of heating and loading cool loads, and also it will add up to your knowledge when you try to apply for your heat load analyst exam. Okay, so we'll talk about power consumption and heating and loading loads of lighting, appliances, pool and spas in a house. We also will be able to calculate the power consumption of lighting, appliances, and pool and spas for heating and operation. And one thing I would like to say is that whenever you have an appliance that is consuming electricity, probably there is some kind of heat emission coming out of that. So that is something we have to account for. And mostly the heat coming out of appliances is counted when it comes to cooling load. It's more of a heat gain than something as a heat source. What does that mean? Like when you're trying to heat a house, you do not count the heat coming out of the appliances or light as a heat source, but it is there. It could help if it's on. And in the summertime, these appliances that emit a lot of heat are going to be something that you have to count for when it comes to cooling. Okay. I'll give you some also guidelines about lights, what kind of light do we need, and again there's a big initiative now by the state and in the entire nation to change lights to LEDs. LEDs has been really great help, and they have evolved a lot and they cost much less than they used to. I remember 20 years ago when I was in college, the whole movement was toward changing from incandescent lights to CFL, and things has changed a lot since then, and now we have LEDs, which is actually one fraction of the incandescent, and probably one quarter or less than that for CFL. So 60-watt light bulb incandescent can be replaced by 10-watt CFL, and can be replaced by 5 watts LED. So that's really good improvement. So lighting is very important, and our consumption of power in house is HVAC, lighting, and appliances. This is what we use to consume power in a house. Energy consumption of lighting and appliances as a percentage, 10 to 50% of the percent of power consumption come from appliances and light. So it's not that small, so it's something to consider. Uh, so when we are in construction or trying to reduce the power consumption of a house, it's good to consider the lighting, and it's also good to consider the appliances, because that will contribute to your power bill. So why do we care about lighting? Again, just an example here. I'm not going to ask you this, but this is the amount of heat that is emitted by lighting. Whether it's incandescent, probably you can tell that the lights makes a lot of heat and emit a lot of heat, so it's an issue when you use floodlights or incandescent lights. With CFL, which is compact fluorescent lights, it's also there's a lot of a ballast factor, and there's a lot of power heat generation. LEDs are the best because they do not produce a lot of heat. So this equation here just shows you how much heat you get out of light bulb. But don't worry about that much. Again, this is the power consumption. Lighting is it varies between 200 to 1000. So this is energy consumption of kilowatt hour. The fridge, again, between 500 to 2000. There are ways to reduce the power consumption of fridges or refrigerators, but again, it's something that has to be there and on all the time, but you can make it a little bit less. Other appliances that consume a lot of energy is clothes dryers, washers, TV. Not anymore. Now TVs are made out of LED and they don't consume as much. Sun pump or hot tubs and spas, but again, it depends on the frequency. How often do you use these? Computers also are no longer a factor in this equation. So starting off with lighting, light should be task related. We should put light wherever we need it. And so for task related, when you do office work, sewing, craft, or cooking, you need a lot of light because you have a lot of focus, and that will reduce your exhaustion of doing the task when you don't have a lot of light. Probably you have noticed if you're doing some kind of small intricate work that if the lighting is not enough, probably you will get exhausted and tired quickly. If you have indoor plants or pet care, for example, reptiles or fish, or you grow some plants or flowers, probably you need to have plenty of lighting for that purpose. Decoration, it's very, very important to have the proper amount of light. Otherwise, the ambient and the atmosphere of wherever you are is not going to be comfortable. There's a whole science and there's a whole engineers dedicated for lighting when it comes to decoration, whether it's commercial or residential or just for function. Security, again, security is very important. A lot of offices and business buildings, they keep their lights on just for security purposes. And again, the advances has been a lot now when it comes to motion sensors and also infrared sensors, so you can use the lights whenever it's needed. You don't have to keep it on the entire time. I mean, even with LEDs, it's consuming power, even though it's very small, but still there's some power consumption. Efficacy. What is efficacy? It's a term that means efficiency measured in lumens per watt. How much is this illumination is effective to the task we're doing? So it's lumens per watt. So how much power consumption I'm doing and how much lumens am I getting? So is most of the energy is converted into light or is going to heat or other stuff? So the rest of the watts goes to heat. You are producing heat, which actually not the purpose of this light. Sometimes it is if you're using infrared to heat food or to heat a tank or to heat plants or air, that's possible, or for cooking, but that's not the purpose when it comes to light. Is it always a bad thing? Not really. Again, if that's your purpose, that's fine. I mean, you go to the restaurants and you see a lot of heat lamps there that they give you light and also heat, and it's radiation heat, which is completely different than convection heat. It's the best way to keep the food warm without drying it out, and it feels comfortable. If you go outside and sit in a restaurant, there's a lot of radiators that actually give you a lot of infrared heat instead of hot air. There is something called dirty electricity. We've been talking about it for a while, but now that's not even an issue. It was a problem with with the fluorescent lights, because there's some high frequency going on, but that's not going to be an issue anymore because most people now are using LEDs and it's the most dominant light in the field. So economics, when we think about light, we have to think about purchasing cost, operation cost, lifespan, and these are some examples. So if we look at the efficacy, the lumens per watt, you get a lot of metal halide or high pressure sodium, especially when you want to do stuff in stadiums or places where you need a lot of lights or stages. These are very expensive, but they do last a long time and they give you a lot of light, a lot of lumens per watt and other stuff. LEDs are not in that chart because, again, it's a recent advancement. When LED first came out, it was almost $20 a piece. Now they're more economical. So you have to think of the purchase cost, operation cost, and the lifespan. So luckily, in the last 5 years, LED has been the most dominant lights for residential and for commercial, and it's becoming more and more versatile. Lumens and illuminations, some definitions. Lumens are the output of light bulb based on efficiency. Illumination is the distribution of light on a horizontal surface. So if you have a light that is flooding, where is the light going? Is it going in one surface or going all over the place? Is it like scattered or is it focused? So that's the illumination. Foot candle is a lumen of light distributed over a square foot. This is a really nice definition to have if you are going to go into some kind of decoration or choosing lights for that surface or that place. The minimum illumination of a 100-foot candle is the lowest to perform visual task. This was the old. This has been changed to 30 to 50. That's enough. Again, too much light can also be exhausting, so you have to have the right amount of light. There's a lot of study and a lot of research going on in this area, and probably you personally have noticed that when you go to a place that is very, very highly lit than a place that it's dim. So there's a big difference. Long tasks such as sewing, you want a lot of light because it will keep you alert and it will make things a little bit easier to see when you're doing these lights. The lighting color is something you have to pay attention to because, again, it has a lot to do with decor, with comfort, and also with task. It goes to cool to warm, it's also blue to green. So cool colors are mostly lean toward blue, and they're good for contrast, and it's better for reading. Those goes more to blue and more of kind of white blue. If you go to warm, it's mostly goes up towards orange or yellow. So if you go to Home Depot and look at lights, they always give you that number based on kelvins. So they, if, again, for showrooms, you want warm light because it's really better for colors. And there's some stuff in the book about the coloring index and rendering. Here's one of the temperature, which is actually in degree Kelvin. So 10,000 is very high, 5,000 is more kind of still cool, which is blue. And if you want warm light or like daylight, you're gonna stay between 4,000 and 2,000. So 2,000 is sunrise, sunset, candle flame. High pressure sodium give you 3,000. So again, this is sunlight between 2,000 and 500 kelvins, and probably you will see this label on the light box. Light quality, it's good for visual comfort. You want also uniform brightness. You don't want one area to be bright, the other way areas having glare or dim, because that again will make you feel a little bit tired. The absence of glare is very important. Again, screens like plasma TVs, not plasma anymore, LEDs, they try to work with glare. Glare is an issue because it makes things a little bit uncomfortable, and it will lead to uncomfortable and uneven light distribution. Direct intense sunlight is not something that is desirable. Pupil frequent shifting can also cause you to have fatigue. Like if you switching frequently between bright and dim, that will cause you to have a lot of issues when it comes to exhaustions and fatigue and being tired. And probably you heard about the blue light. And if you look at your phone, there is something called the eye comfort, which is the degree of light and the color of light. There's also some kind of pollution of blue light, which is the screen light. There's a lot of research that has to do with light, because again it does affect you when it comes to sleep. This is a typical light bulb label, and you can see here they give you the lumens, and check out the kilowatt hour cost here. That's going to be very variable, right? Probably by now you know how to do this calculation by yourself. And warm and cool, so they give you the scale and energy used in watts, so you can always calculate how much this will cost you to install this light bulb. Type of common lights: incandescent, fluorescent, lower pressure sodium, high pressure sodium, and light emitting diode, which is LEDs, and it's the most common right now. So incandescent lights, they're cheap, easy to replace, very common. The cons are they're inefficient, meaning that they make a lot of heat, which is not what we want, and they have short lifespan compared to CFL and LED. Again, you can get the bulb for like 50 cents, but there's a lot of subsidy for LEDs now. You can get LEDs for almost the same price. Fluorescent lights, current running through mercury gas and sometimes other kind of gas. So again, it was also an issue with fluorescent, that if it breaks, it's an issue. It comes in tubular, it is either tube where you fill this tube with gas, ionized gas, that you make it glow when you run current through it through a high frequency. CFL, which is the little bulb, it's called compact fluorescent lights. The pros is 4 times more efficient than incandescent lights. They come in different temperature. In the first one it came, it was completely blue. Now it's different temperature. They last longer. The cons: they're expensive, initial cost. They have mercury contents, and they have high frequency as well. High intensity discharge. These are for usually they're still used for concerts, for stadiums. They have very high efficacy, very intense. They take too longer to. They have very high initial cost. Some of the cons is like again, high intensity, so you cannot modulate it. It does not adjust. It comes only at high intensity. They're suitable for outdoors. They're very slow acting. Probably you have to turn it on and wait for like 10-15 minutes for them to get full capacity. That's what they look like. And again, they are very expensive. So some means to reduce light energy cost: relamp, meaning change the light bulbs, clean the fixture so you can get more efficacy, get the right level or size. You do not want to overlight the place or have high wattage than you need. Also, using natural light is a very good way to do it. There is no substitute to natural light, so it's good to have windows. And actually, there are some skylights now that they can go through 2 stories with the mirrors and magnifying glass as well. Also, use the right light fixtures. You want some floodlights, and you want the light to be where it's supposed to be and the right distribution. And now there's so many options and so many ways to do this the right way. Dimmers and snap switches are very useful because you get the right amount of efficacy, and also you have the right time. So, for example, for a closet, you do not need to leave the light on the whole time. You can just time it and have also motion sensors. Photocells, activated switches. This is a kind of the night lights. They only activate during the night. Optimization is key. I mean, yes, you can have a light bulb that consume only 10 watts, but if you have 10 of those, that's 100 watts. And over time, this will cost you some money. So you can have a potential saving of 50% of your power bill. Paint color selection. What is that? If the room is dark colors, probably you do need more light. You can reduce and save the amount of light by having light colors. Print colors and font. Aesthetics. Reduce aesthetic light. There are some lights that have no purpose, but just to make things look different and bright. So they are kind of useless, and so it's better to not have them or have different kind of light that does not consume as much energy. Provide spotlights, especially in kitchens and where you need the light. It's good to reduce glare by using the right contrast in a TV or a screen. Also have task-based rooms and lighting. If you go into an office, have an office light and do the task where you have the light focused on what you need to do. Okay, so these are some of the equivalency for light bulbs. Again, the Department of Energy was trying to convince people to switch to CFL, but now everybody's convinced that there are no controversy around LEDs. They came a long way, and they come in different light size and illumination. They're even used in cars. So far, there is no way around it. But you can say here the comparison between incandescent lights and CFL lights and the watts. So it's this is the watts for CFL energy stars. And again, for LED, probably for 60 watt now, you can get 5 watt equivalency. So that is really a reduction by 12 times. So there's no brainer. It is no brainer to get like LEDs replacement. So here's a question to compare CFL to LED to incandescence. I'll let you go through it, and I also have the answers for that as well. How much will it cost you to compare the capital with the running cost? So again, how much would the light cost you, and how much would it cost you to run that light? So it's always good to look at the economics in long term and short term as well. Okay, moving now to appliances. What appliances use a lot of energy? I probably guessed it. The fridge is something that you have to have on the whole time, so it's costing you a lot of money. If your fridge is more than 10 years old, it's time to get a replacement that's more efficient. You can cut your energy bill by at least 10 to 20% by just changing your fridge if it's an old-fashioned or old fridge that's not really that efficient. It's a high demand appliances. These are refrigerators, washers, drying or dryers. 80 to 90% of the appliances share the power consumption. Dishwasher. Most of the power of the dishwasher goes to the water heater. So if you can air dry the dishes, probably you'll save a lot of energy. Newer motors are more efficient in terms of like power consumption, also water consumption. They say always use a full load Heat dry option is good. You don't always need to use heat dry. Uh, if you were to buy a new dishwasher, choose one that does not need a hot water connection. Not only it's easier to connect and use, but also it will save you a lot of hot water storage size. Also, try to always pick Energy Star product. For the clothes washers, newer models are more efficient by a factor of 5. Some of them actually they do weigh the clothes and modulate the hot water and the amount of water based on the amount of clothes. So the new washers are kind of smart and they will give you the right amount of energy. Use optimizing water recycling, because again if you're using hot water, I don't know, I mean a lot of people use hot water for clothes, especially for bright colors. That's not always needed. So the water consumption can be optimized for new washers. Also, horizontal, which is front loaders, are more efficient than top loading by 50 to 70%. The reason being is the front loader usually use less energy to spin, so the clothes will move much faster because you're using gravity and tumbling the clothes. Even though they're not very comfortable for people to use, but they save a lot of energy. But again, there's a lot of preference in using top loader than front loading. Energy factor. This is a good information about the energy factor. At some point, the manufacturer were trying to make to commercialize the washers, and they were saying there is an energy factor of such and such numbers, but they were trying to save on the rinse cycle or the spin cycle, so that they can claim that the washer consumes less energy than their competitors. However, if the clothes comes out of the spin cycle still wet, you're gonna use the same amount of energy in the dryer, unless you're using line drying. So pay more attention when you're trying to pick the washer and dryer and what is the energy means, and read the fine prints. So clothes dryers, line drying is very efficient depending on where you live and the humidity, but it's an option, and it actually does save your clothes and make them last longer. Gas dryers, they cost around like 30 to 50 cents per load. They will save you some money, but the safety comparison to having gas line to having electrical dryer, it's kind of outweighs the savings. So you want to use electricity, because depending on how much you use the dryer. If you use a dryer at least 4 or 5 times a day, maybe then you should use gas. But using the dryer for like 1 hour a day or 1 hour a week it depends on your consumption. If you don't have a gas line in your house, I will say using electrical drying is way much better than using gas dryers. So humidity sensors, they save up to 5 to 15% of the energy, because sometimes the clothes are dry and you're just like running the heat for no reason. Cleaning the filter is a very important part of the dryer, because again it will take you less time to dry the clothes. Fridges and freezers, they account for 9 to 15% of the energy consumption in the year. They run all year round to maintain your food at that temperature, and even though the compressor might not be engaging, it has to maintain the temperature. So most efficient ones can use less than 500 kilowatts per hour, which amount up to 500 kilowatt hour per year, 75% dollars a year. This is the most efficient ones, which is not that much, but again that is considering that you keep it closed all the time. So that calculation does not account for you opening and closing the fridge, which is where you lose a lot of the heat, and putting new food in. So tips for the refrigerators is keep the freezer as full as possible, because that's more mass inertia, more way to store the heat or the coldness, if you say. Defrost when there is 0.25 inches of frost. That's for freezers. Limit the opening times. The more you open and close the fridge, the more it will have to start over again, cool the inside of it all over again. Clean the coil once a year. Depends on the model. Not all freezers need that, so that's something I guess was in the past. Most of the new models are automatic defrost, so you don't need to do that manually. Those maintenance things are something of the past. Now, none of the new models will require coil cleaning or defrost. Side by side, refrigerator and freezer waste more energy. Why do you think that is? Again, because you have two compressors and two compartments to cool. So it's again, it always depends on your on how do you use that freezer and refrigerator. Upright freezer uses more energy than chest freezers. Why is that? Because every time you open the freezer, all the cold air will fall from that freezer. Chest freezer, you can even leave it open and the cold air will remain in the bottom. And that's why probably when you go to the supermarket, you see the freezer all like open with no covers, because the cold air will remain in there, because again, we said like air, even though you don't see it, it's staying in the place because of it's heavy. It's not going to go away. Two small refrigerators use more energy than one large fridge. So it's good to size the fridge you need instead of having two at the same time. Old models more than 10 years uses, again, you gotta check the label. It's more than 1,000 to 2,000 kilowatt per year, which is a lot. Controls, you want to keep your freezer at 0 to 5 degrees Fahrenheit, fridge at 36 to 40 Fahrenheit. That's kind of keep your fridge optimized. Pools and spas, again, not very common, but it is common. Not a big issue for spas and pools, because unless you keep them hot the whole time, it's how often do you use them. But water heating demand, you want to keep the pool at 78 degrees. So heating the pool from the start of heating of the pool is not a big. It's where you consume most of the power, but maintaining the heat depends on how much heat you lose out of that pool or spa. Uh, so the heat is just for maintenance. The other energy that you will use for pool and spa is the circulation and the pumps. That's where you consume a lot of energy. Hot tubs are kept at 102 Fahrenheit and sometimes 105, which is a lot of energy to keep adding on. Check out also solar pool heating options in chapter 9 in the book. There are some ways to heat a pool using solar. Pool covers and evaporation. Pool covers are very useful for evaporation, and also during even summertime when you heat the pool and when you use the pool, it's good to cool the cover to eliminate evaporation, also maintain the heat inside the pool. Pumps use a lot of energy because you keep them on the whole time to run the filter, and also keep the water from being stagnant. And stagnant water is where you have a lot of issues and sediments. It's time related. Whenever you have a lot of elbows and you have the pump very far from the pool, is when you consume a lot of energy. And pumps do consume a lot of energy, but be mindful of how far it is and how well it is maintained. So another thing we have to think about, and that's people heat gain. People do not think about that when you are designing for cooling. Again, when you're trying to cool a place, you gotta understand, whenever the more people you have, the more heat. People produce a lot of heat as well. So if every person is around like 75-watt light bulb, so if you're sitting in a place, every person is emitting around 75 watts of heat bulb. That's sensible heat. Latent heat is around 55 watt. So that is something really you gotta think about when you design for big hallways or big house with a lot of people in it, or even workplace. So if you're in a gym, you're probably producing more than 210 watts, and this can be converted to BTUs as well. And you're sweating and making more heat. So this is a really good piece of information to have when you're designing cooling systems for a house or a place where there's a lot of people. Okay, that's all I have about appliances, and check out the chapter in the book. There's a lot of tips about appliances, and again, these things always keep being updated. Always look for the energy storage equipment and look for the power consumption, and also try to read the fine prints for these appliances. Thank you.